Namaste to all. My name is Shra Singh and my topic of presentation is ring. What is ring? The structure R plus multiplication consisting of a non-void set R and two binary composition denoted by plus or multiplication or dot is said to be a ring if the following axioms are satisfied. That means to be a ring, for any group to be a ring, there are three important conditions. If it's satisfied, that it is a ring. The first one is R plus should be an abelian group, and the second one is R multiplication or dot is an semi group. That means it should be associative. First of all, we must understand what is a abelian group. For a group to be an abelian group, it it should have its inverse, identity element in it, associative element in it, commutative in it, and the all should be a closure. The all should hold closure property. So for an abelian group, there are four conditions. That means it should have inverse, it should have identity, it should hold commutative as well as associative property, and all are closed. So these are condition for abelian group. So for ring, R plus operation should be an abelian group. R multiplication or dot operation should be a semi group. That means it must hold associative property, and for every A, B and C belongs to R. The third condition for a group to be a ring is to hold left distributive law and right distributive law. Left distributive law says A multiplication B plus C is equals to A plus B multiplication of C. Thus we see that the ring R plus multiplication satisfies the following property for every A, B, C which belongs to R. Here R plus is an additive group. Additive group, what we mean about additive group? Here 0 is an additive identity. When we'll add A to 0, and it will always be equals to 0 plus A. So this is called additive identity. And if we add A minus A, then it will become 0. So minus A is additive inverse. Okay. And for R multiplication, we have multiplicative inverse here. In R addition we have additive inverse, and in R multiplication we have multiplicative inverse. A inverse is multiplicative inverse, and in for a ring it is not necessary to have multiplicative inverse, as if it is there, it is not necessary to have multiplicative inverse, but in case if it is there, then it is a special type of ring which is called ring with unity. Now the types of ring. We'll study the special types of rings. The first one is ring with unity. Right now we discussed that in R multiplication, if there exists a multiplicative inverse, then it is a ring with unity. The another one is commutative ring. The commutative law must hold here. That is why it is a commutative ring. A ring R plus multiplication is a commutative ring when it holds the law of commutativity. That means A cross B is equals to B cross A for every A, B which belongs to R. Okay. The another one is zero ring, null ring or trivial ring. Set R with only one element in it. That is, when we have a set which has only one element in it, then it is known as zero ring or null ring or trivial ring. As we know that here the multiplicative inverse as well as the additive inverse both exist. Multiplicative inverse and additive inverse both exist. Therefore, this is an zero ring. Okay. Z plus is a group, but Z multiplication is a semi group. You know, Z plus is a group, but Z multiplication is a semi group. As here, why it is a semi group? Because in this Z multiplication, the multiplicative inverse does not exist for 0. Does not exist for 0. As you know that for 0, the multiplicative inverse is to be 1 by 0, and you know that this is not defined at all. So for 0 the multiplicative inverse does not exist. Therefore the Z multiplication is a semi group. So here we have the property that Z plus multiplication is a ring. because in multiplication there is no necessity of a group to be an abelian group or any special type of group. It must hold only one property, which is more important, that is associative property. Matrices is not commutative. We have already studied in class 12 that AB is never equals to BA in case of matrices. That means it is never commutative. Therefore, when it is never commutative, then it is not a ring. Matrices are not a ring. Reason being, we have to, the first condition is that Z plus operation, for Z plus operation, it must be holding the property of an abelian group. And in abelian group, it is very important to be a commutative. These are some elementary properties of a ring. Theorem says for any element A, B, C of a ring R, when we'll multiply A by 0 or 0 by A, the answer is always A, 0. When we multiply A with minus B and minus B with A, then the answer is minus in the bracket A, B. When we multiply minus A with minus B, we'll get positive AB. When we'll multiply A by B minus C, we'll get AB minus AC. And when we'll multiply B minus C by A, we'll get BA minus CA. In these theorems are very important as it comes in proving. Here are some more special types of rings. The first one is zero divisor in a ring. An element A which is not equal to 0 of a ring R. When we will take product of two non-zero element, it must be equals to 0. Then the element A is called the zero divisor of a ring. We know that we'll just take two elements, that means A and B, which both belongs to a ring R. So A is also a non-zero number and B is also a non-zero element. Okay, both are non-zero element, but to be a zero divisor in a ring, the product of these two non-zero elements must be equals to 0. So, if this condition satisfies, then we can say that it is a zero divisor in a ring. The second one is ring without zero divisor. For ring without zero divisor, we must have, there is a condition that either A must be equals to 0 or B must be equals to 0. Then the product of A and B will be equals to 0. This is the condition for a ring without zero divisor. If AB belongs to R, then AB is equals to 0 when A is 0 or B is 0. So for example portion of the first one, that means zero divisor of a ring, we'll take that matrices A is equals to 1 0 0 1, which is a non-zero matrices. Also a B, which is also a non-zero matrices. But when we'll multiply these two matrices, we'll get the zero matrix, that means a null matrix, which satisfies the condition of zero divisor in a ring. Boolean ring. A given ring R plus multiplication whose all elements are idempot is known as Boolean ring. The meaning of idempot says when you will take A square, it must be equals to A. So this holds in case of 1 and 0. So we know that 1 and 0 is a Boolean ring, as we know 1 square is equals to 1 and 0 square is equals to 0. So we can easily say that this is a Boolean ring. Characteristic of a ring. When we add plus a plus a plus a with n times and then its sum is 0, that means na is equals to 0 for every a belongs to R. If this type of n exists, then we can say that R is a ring with finite characteristic. That if n does not exist, then we can say that ring with finite characteristic as equals to 0. That means if n exists, then we can say that it is a ring with finite characteristic, and if n does not exist, then we can easily say that it has finite characteristic is equals to 0. For example, z4 plus 4 and multiplication 4. Here you know that n is existing here as 4, so we have characteristic is equals to 4, and here it is not given for which modulo we have to apply this operation. So we can say here that it has characteristic as 0. Thank you. This was all for ring.